Good morning. So now we go to the next part of the lesson. I want to talk about powers and exponents. This is also not something new, definitely for you. You already know about them a lot, but we want to complete it a little bit more and solve more interesting problems sometimes. So something that you want to know about powers and exponents is that mainly the reason that we are interested in powers is because we want many times. Hello, the lesson has started. Hello. Okay. So many times in mathematics it happens that we have the same number multiplied by itself a number of times. If that is not that much, we can just be patient and write it. For example, we can write 2 times 2 times 2. But sometimes we have to multiply, for example, 2 by itself 100 times. It's still in principle possible to write 2 times by itself 100 times, but it becomes quite big and it's boring. So it's better to invent a notation and then have the convention, so whenever you see that notation, you understand what we mean. It's easier. And that is why, that was the motivation behind of introducing this symbol of powers and exponents. So for example, let me say A is a number for you, is a real number. By a real number, I mean any number that you can imagine, of course. There are also other numbers called complex numbers, but forget about them. Whatever number you have, we call it a real number. So let me A be a real number. For example, 1, 5, -3, 1 over 5, the square root of 5. These are real numbers. Pi, the famous pi number, all of them are real numbers. Any number that you imagine is a real number. And now, let me, for the time being, limit myself to n. N is a natural number. Natural number. What do I mean by a natural number? I mean this list. 1, 2, 3, all 4. Positive numbers. All not positive numbers, because 1 over 2 is also positive, but it's not a natural number. 1 over 2 is a fraction. Only these numbers. Yes? Whole numbers and that are positive. So these are the natural numbers. Now, you might see this symbol in mathematics text a lot. You see that you have a number here, but you put a little bit smaller n on top. This is what we call powers and exponents. So the whole thing is called a power. And this part is called the exponent. And this part is called the base. So these are the terminals. So if I say a power, I mean the whole package. The number on top, the superscript is the exponent, and the one is called the base. For example, you might see something like this, 2 and a little bit smaller 3 on top. How do you read it? You read it 2 to the third. Or, yeah, sometimes I say 2 to the 3 for simplicity. But if you want to be precise, you have to read it 2 to the third. Okay, what does this symbol mean? It means that whenever you see this symbol, you have to start multiplying the base by itself how many times the number that appears here. So this means 2 times 2 times 2. So be careful. Still, I see some students say immediately 6. That's not the product. It is not the product of 3 by 2. It means multiplying 2 by itself 3 times. So 2 times 2, 4. 4 times 2 is 8. So the answer to this is 8. And I told you that even though for the time being we have this restriction that n is a natural number, but we do not have any restrictions for what I choose for the base. Base can be any number. For example, I can ask you, what is 1 over 5 to power 2? Or the second power. By the way, there is a particular name in English for the second power. It's called 1 over 5 squared. And if I have power 3, I can say 2 cubed. So that's also the way that you read. So you see here, you shouldn't get confused, because I have a fraction. If I ask you what is this, you will tell me this is a power. If I ask you what is the exponent, you will tell me 2, which is good because the exponent should come from this list. And if I ask you what is the base, you say 1/5, which is also possible because the base can be any real number that you like. But what does it mean? It means take the base and multiply it by itself. How many times? The number that you see up there, 2 times. So in this case, 1/5, 1/5. And then forget about this, becomes the previous lesson. You are facing a fraction, multiplying another fraction, and you already know the rule. So you have to multiply 1 by 1, which is 1. You have to multiply 5 by 5, 25. So if I ask you what is the second power of 1/5, or what is 1/5 squared, the answer is 1/25. Is that clear?
Yes.
Okay. So that is nothing special. But before actually proceeding a little bit, I want to make sure that you really know how to calculate some things, okay? So there are different things that we can discover together, okay? So let me just write an example, and I want you to find a final number. By the way, if I say 2 to the power of 100, it is understandable for us, but the number is big. For example, like 10 billion. 10 million is more or less understandable, but it's a quite big number. 2 to the power of 100 means you multiply 2 by itself how many times? 100 times. And it grows exponentially, so it becomes very, very big. You multiply 2 by 2 is 4. You multiply it by 2, it becomes 8, not that big. You multiply it by 2, 16. You multiply it by 2, 32. Multiply it by 2, 64. Multiply it by 2. 10 times it becomes 1,200. So even if you multiply 10 times by itself, it becomes 1,024. Multiplied 11 times, I don't know, 2,048 or something. So it's not big. But after a while, it grows exponentially. I will talk a little bit about. I want you to understand and have some respect for these kinds of exponential numbers because they could be extremely, extremely big, probably beyond your imagination for the time being. I want to come back to this later, but let me first make sure that you can calculate these things. For example, am I allowed to ask you what is 2/3 to the power of 5? Yes. Yeah. Because what matters for the time being that this number should be a natural number. But what happens in the base, not important. So what does it mean? It means write the number in the base, in this case 2/3, and multiply it by itself. In this case, how many times?
5 times.
5 times. So I have to multiply this. 1, 2, 3, 4, 5. And then we know the rule. If I want to multiply fractions, I have to be patient and multiply the numerators. 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32. It becomes 32. And then you do the same thing here. 3 times 3, 9. 9 times 3, 27, times 3, 81, times 3, 243. Yes? That's the number. So I mean, calculating, even though in grade school I might be the emphasis was to calculate things, but in here we don't want to calculate things. What's important for us in high school mathematics is to understand that two numbers are equal, even if both of them are written in the form of exponents. This is, I will talk about them. But for the time being, let me just review things. That's extremely simple. Let me give you another example with negative numbers. For example, if I tell you -3, by the way, that is important. From now on, I want you to learn that. If I write this, and I write this, they mean different things. Okay? I want it, of course, they mean different things, but in this case, the final answers are the same. It is extremely important in mathematics to appreciate the differences, yes? I don't want to answer that. Yes. So they are different, but the answers are the same. How we understand that? If I ask you what is -3 to power 3, it means that I have to take the base. Please read it for me. What is the base?
-3.
-3. What is the exponent? 3. So I have to take my base and multiply it by itself. How many times? 3 times. And then it turns out -3 times -3 is +9. +9 times -3 is -27. Okay? But if I ask you to write this, so what is the answer to this?
Minus 27 still.
Now, how should I write it down?
Oh.
So this minus sign, so when I write minus 2, what does it mean? It means that whatever number you have, then you multiply it by a negative sign. For example, if I ask you, can you calculate this for me? What's the answer? It is 2. Why? Because first you calculated this, it becomes 2, and then you multiply it by this negative sign, it becomes minus 2. Yes? But in this case, you should also do the same thing. So what I have to do? First, I have to calculate this. For example, if I ask you what is the base, what is your answer?
3.
The answer is the base is 3. Yes, the base is 3. But what happens this time? You be careful. If I ask you what is the base, you told me minus 3, which was true, which was correct. But if I ask you what is the base, if you say again minus 3, that is wrong. It is not one exponent. It is one it is one power multiplied by a negative sign. So in principle, if you want to calculate this, you have to respect and calculate this part first by multiplying 3 by itself how many times? 3 times. And then if you insist to put a pair of brackets and then put a minus sign. So you see the intermediate step that I am writing here and here, they are different. But the answers are coincidentally in this case the same. So both of them are minus 27 in this case. Yes?
Is there an instance where the answer is not going to be the same?
Yes, and then you can guess what? If the exponent is an even number. So let us calculate this one. For example, if I give you minus 2 to the power 4, and that's extremely important to understand it right away. Okay, and then send it to your memory. Okay, so minus 2 to the power of 4. If I ask you what is this, you will tell me this is one single power. If I ask you what is the exponent, you will tell me 4. If I ask you what is the base, you will tell me minus 2. Okay, so this means that I have to take the base, which is minus 2 in this case, and multiply it by itself how many times? 4 times. Yes? But here, minus 2 times minus 2, positive 4. Positive 4 so far, multiplied by negative 2, negative 8. Negative 8 so far, multiplied by another minus 2, positive 16. I will come to, yes? And then here, what I'm supposed to do, I have to, if I ask you what is the base, you should say that this is not one power that I can tell you the base. This is one power multiplied by a negative sign. So this means that you have to do the power part first by doing 2 by itself 4 times and then put a minus sign here. And then what is the answer? Here it becomes 16, but then you have a minus sign at the end, so you put a minus sign here and you immediately realize that the answers are not the same. Yes, what's your question?
It's not really a question. I was just going to see if I understand it correctly. So basically, if it doesn't have parentheses, it always forces it to be negative instead of when it has parentheses, it's always every uneven.
Yes, if you want to find a rule of thumb, that's correct. But I want you to understand. So in principle, if you want to summarize this, I want you to say that, first of all, I want you to understand, are these mathematical creatures the same thing? The answer is always no. Yes? But the answers turns out to be the same. Yes? Because this means this operation, you see, you can feel the difference. This, what I have written in the intermediate step, is not identical with what I have written here, but it is coincidentally the same. So I would say that in principle, I would say that the final answer between these two cases are the same if this number is an odd number. And the answer to these things are always opposite. I don't say just different. Of course they are different, but we can say more than that. They are not only different, but they are opposite. So I would say that the difference between these two way of writing matters by a minus sign. Which one will be positive at the end? The one which contains the negative sign. Which one will be positive at the end? The one which does not contain the pair of brackets. Yes, it's good. After understanding, that's exactly what I do. First I understand, then I will try to find a rule of thumb to send it to my memory. Because every time, if you want to spend a lot of time to think and find everything from scratch, for simple problems it works, but for harder problems it will not work. Okay. So there are many things that you can immediately do here. For example, again, the priority rules. For example, if I ask you what is 4 to power 2 plus 2 to power 3, you really don't need a teacher to tell you which one has the priority. So here, how many operations are involved?
3.
Yes, three kinds. I mean, here we have one multiplication. How many multiplications we have here? 2 multiplications in between, 2 times 2 times 2, and I have one operation of addition. But do you need a teacher to tell you which you would to do first? No, because the teacher is only allowed to ask you to add 2 numbers if the teacher actually gave you the numbers in the first place. Yes. So if I ask you to do this addition, this is my responsibility to give you the numbers and then ask you to add them. So this is exactly what you want to do. If you want to do this operation, there is only one way. You need to understand the left-hand side of that operation. You need to know the right-hand side of operation. So in principle, it means the priority is given with the powers. Yes, you don't need to memorize that, but anyway, if you want, you can use that rule. So here, if I want to write it very precisely, I would write that, okay, let me just open a pair of brackets, even though it is not necessary here, but let me just emphasize here. 4 to the power of 2 is what? 4 times 4. 2 to the power 3 is 2 times 2 times 2. And then 4 times 4 is 16. 2 times 2 times 2 times 8. And then I add them. So the answer is 24. That's it. And it doesn't matter how advanced your mathematics is, there is no rule for doing this. We will read some rules. For example, if I give you 4 to power 2, 4 to power 3, plus you know what to do. Yes? You can write 4 to the power of 5 from Grun School. Okay? But there are no rules. There is no other way to do this. Okay? This I want you to understand. So you don't have any problems with powers. Unless, of course, there are very important things coming up with powers. For example, right now, let me draw your attention to it. What does it mean if I write 2 to the power of minus 2? I want you to understand that this is not going to work as simple as before. If I write 2 to the power 2, it is clear. I multiply the base by itself 2 times. But when I want to do the same thing here, then I will start laughing. Yes, what does it mean even? Multiply 2 by itself minus 2 times. It doesn't make sense. Or even if I write 2 to the power of 1/3. Yes? What does it mean if I say multiply 2 by itself 1/3 times? Yes? Or that doesn't make sense. Yes? But if you take your calculator and punch these numbers in, the calculator will give you an answer. I just want you to understand how the calculator knows that the answer is the answer to this is not very easy to understand. We have to go through it. I will not be able to cover it because if you want to understand powers and exponents, you need more advanced mathematics. But I can tell you the ideas, okay? But for the time being, that is why I am limiting myself to natural exponents. Yes? Then in that case, it makes sense. Whatever I have as the base, I multiply it by itself the number of times that appear in the exponent. And this is meaningful. You understand what I mean? So I cannot just teach you this and then ask you to calculate this. No, there's no way, because it doesn't make sense. So I have to change my definition. Okay, so let me see how do you do this. For example, 3 to the power of 2. Yeah, just do it for me. 3 to the power 2 minus 6 to the power 2 plus 4 to the power 2. Yes? Yeah, can you calculate this? I write some items here and wait for you. These are very, very elementary things, but I just want to make sure that you really understand what to do. Okay, so what is the answer to the first one? So you see again, I have 3 to the power of 2, 6 to the 2, 4 to the 2, but I have subtraction and addition. If you have these operations, you cannot do them unless I give you the numbers. But I have given you the numbers in a little bit strange way. I have put some work on you to do it. So first of all, it's better to do it in your head, by the way. So 3 to the power of 2 has a better name. What is another better name for 3 to the 2? 9. So I would write 9. And then I ask myself, what is 6 to the 2? Is 36. How did you find that? You just multiplied 6 by itself 2 times because that's 2, but there is a negative sign, so that's negative. And don't get confused, this 2 is not affecting this negative sign. Yes? And then 4 to the power of 2 is how much? 16, and then I have addition. But that's just a normal calculation. So minus 36 plus 16 is minus 20, and then I have here, it's minus 11. Yes? And now if you go to the other one, I want to do this operation. If you want to do the division, I have to give you the numbers and then ask you to divide. But I have given you these numbers in a little bit disguised form. So what is another name for 10 to the power of 3? It's that, by the way, there are some numbers that calculating the powers are extremely simple. Let us just review them. Do you know these numbers? For example, the simplest possible number whose any power is very simple is 0. 0 to power 1000, what is the answer?
0.
0, because you are supposed to multiply 0 by itself 1,000 times, yes? Another number whose powers are easy to calculate, extremely easy, that is?
2.
No, 2 is hard. After a while it becomes hard. 1. 1 to the power of 1000 is? 1, because you are supposed to multiply 1 by itself 1000 of times. That doesn't. Another number that is easy?
10.
10. 10 to the power of 1000 means
It's
1 with 1000 zeros in front. It's a huge number, but it is easy to calculate and understand. For example, if I say 10 to the power of 6, it is extremely easy. It's 1 million. 1 with 6 zeros. Yes? There is another number that is easy to calculate. You missed that one. 0, 1, 10. There's another one.
100.
5 is not easy. For example, if you tell me 5 to the power of 10, I don't know. I have to
100.
calculate. No, of course, yes. Any power of 10 is easy, yes? Forget about powers of 10. But minus 1 as well. Yes? Now let me ask you. Minus 1 to power 100. The answer?
minus 1.
No, 1. Because minus 1 to power 100 means multiply minus 1 by itself how many times? 100 times. But 100 is even. So pair-wise, they cancel the signs. But minus 1 to the power of 1001. Minus 1, because there are odd numbers. So remember, 0, 1, minus 1, and 10. These are the numbers that are extremely easy to write down the powers. Yes, yeah?
Any number to the power of 0, does that become 1?
Yes, I will come back to them. It depends on the definition. Yes, but that is the definition. Okay, so here, 10 to the power of 3 is how much? 1000. 5 to the power of 2 is? 25. And then I'm supposed to divide them. I hope that you can do that, it becomes 40, yes? And now here, I have a difference, a subtraction, addition, and powers and pairs of brackets. So here, it is extremely important to put the pair of brackets. So the priority is with a pair of brackets. It's always the priority. So 5 minus 2 is how much?
3.
Is 3. So I have to do this one first, 3 to the 4. And then I have a negative sign, but there is also another pair of brackets, so that's the answer is 7 to the 2. And now I can ask myself, what is 3 to the power 4? Means multiply 3 by itself 4 times. 3 times 3, 9 times 3, 27, times 3, 81. That's correct. Minus 7 to the power 2 is how much? 49. And then the answer is 22. Oh, sorry, 30. Thank you. So the answer is 32. Okay, so that is actually simple for you. Now I want to come to your question. You could ask a number to power 0. Now you see I am deviating a lot about something. Because I told you that in my list of exponents, I have only 1, 2, 3, and 4. And then the goal, one important goal of the lesson is to expand this to contain more numbers for me. The first thing that natural is what happens if I add 0 to this list. So if I have a number to power 0, it is defined to be 1. When I say it is defined to be 1, you might say why it is not defined to be 10 or why it is not defined to be 7. There is no why for it in mathematics when I define something, but there is a motivation behind that why mathematicians have chosen this convention or this definition. For the time being, consider this, that if A is a non-zero number, if someone tells you what is A to power 0, then you will say 1. And then I put semicolon equals to. When you see semicolon equals to, in mathematics it means it is equal to 1 by definition or by convention. Because usually in mathematics, whenever I say, you have right to ask why. Yes? But here, when you see semicolon to be 1, it means that this is a convention. You still can ask the motive behind the convention. Why this is a good convention. This we can ask, but at the end, mathematician doesn't care. They say that if you agree with me on this and be patient, I will take your hand and show you these consequences, which are actually good and interesting or useful. That's the way that it works. So if A is not 0, any number to power 0 is defined to be 1. But then I will talk a little bit about this later, why this is a good convention. Because some people I have seen write it in this way. They say that, okay, so they want to say 2 to power 0 is 1. They bring this argument. They say that, okay, what is 2 to power 2 divided by 2? So what is 2 to power 3 divided by 2 to power 3? By the way, that's a good, I can explain it here for you. On the one hand, you have to admit this is 1. Do you agree?
Yes.
Because if you don't admit this, then you have to throw all mathematics that you have learned away. In all mathematics we have learned so far, if I have a fraction whose numerator and denominators are the same, what is that fraction? 1. 5 over 5, 1. 10 over 10, 10. 1000 over 1000. So, on the one hand, if this is not going to be 1, I am in trouble because I want to keep it. Otherwise, I have to throw the previous mathematics away because of something that I am teaching now. So this is not a good, reasonable thing. But on the other hand, do you know how can I write this according to the rule of powers? We will learn later that you can write 2 and then you subtract the exponents. Okay? So then it becomes 2 to power 0. And they say that, okay, now you see I proved that 2 to power 0 is 1. This is not a proof. But this is the motive behind this convention. Because if you have this convention, then everything remains consistent as it is. So it is a good motivation behind that definition or convention. Is that clear? Okay. Now, for example, if I tell you this, 1000 to power 0, the answer is immediate. What's the answer? It's 1. But there is one exception, and that is some disagreement between mathematicians. It depends on the book. What about 0 to power 0? Some people say no. That's what I'm saying. For me, it's better to call it undefined. Undefined in the sense that when you write 1 over 0, it is undefined. But some mathematicians say that let us define it to be 1. I also understand what they mean. So that is not a good, you see different conventions. Let us keep it like this. We have our convention in our class that when you see 0 to the 0, you can say it is undefined. Yes? Because on the one hand, we have 0 to any power is 0. On the other hand, we just told you that if the exponent is 0, it is supposed to be 1. So 0 to the power of 0 is a little bit confusing. We don't know which way to go. Okay? So in those cases, let us say that 0 to the 0 is undefined for our class. Okay? It doesn't matter. I can see, you can Google it around. By the way, you can use calculator. Do you have calculator?
Can't be divided by 0.
No, 0 to power 0. Can you punch this?
0 to power
Let us see how it works there.
0. 0 to power 0. How do you add power?
Flip your phone and it'll get it.
What is the answer?
Wait.
Error.
Error. Okay. So I would say that even though the very brilliant mathematicians define 0 to the 0 to be 1 still, but you see at least in the calculator 0 to the 0 is undefined. Exactly like that. If you take your calculator and you divide this, you get something undefined. So for our class, we consider 0 to the 0 is undefined. Okay? Agree? Okay. These are some information that you want to have. Okay, you see, GeoGebra says 1, another calculator says so. So I mean that both of them are there. Okay, I can understand why GeoGebra says that's 1, because that depends a little bit more of advanced mathematics. Okay, but now let me, before going further, I told you that you have to have a good respect for these kinds of numbers. Okay, and then because we have GeoGebra here, I want to actually first of all try to understand that how big this number is. I want to give a feeling to you. This is very good because in mathematics we can talk about numbers. I can potentially write this 1 billion or 1 billion. So I'm making it bigger and bigger. But let us see how big is just 2 to the power of 64. The reason that I brought 64 is because there is a famous historical problem, and 64 is the number of squares in a checkerboard, chessboard. Yes. So that's why I want to see how big this number is. Okay? Hello? Okay? So what my question is this. If I take this number of papers, A4 papers, and put them on top of each other, it becomes a tower of papers, yes? For example, this normal packages of papers include 500 pages. And I don't know, if you see the thickness is around 10 centimeters or so. So if you put 500 thin papers like this on top, it is not that long, that's not that high. At most it becomes approximately 10 centimeters. Now we want to have, hello, can you hear me? Don't talk when I am teaching, please. Yes? Okay. And then I want to see that if I put this number of papers on top, of course, 10 to the power of 10 is 1024 or something, so it becomes more or less 2 times that thickness. But now assume that you have enough source available and you start putting the papers on top of each other so that the number of papers in that tower is exactly this number. And of course, needless to say, you see that this reaches to some height. Assume that you put it from the ground. I want you to have an estimate in your head, I don't know, about the height of this tower of papers. For example, you can compare it with the Eiffel Tower. How long is Eiffel Tower? 330 meters. Or I don't know, the longest tower we have is, I think, Burj Khalifa in Dubai. So it is around 880 meters or something. So what is your guess? Do you think that this tower will be higher than the Burj Khalifa in Dubai? Or how high will it be? Okay? And this is something, I see that you have your computers here. You should be able to do this calculation by GeoGebra or by calculator. That's an extremely simple calculation. Okay? I want to wait for you to see what is your estimate. Okay, so let us to be on the safe side. Let us consider this: 10 papers. Let us assume that 500 papers in a package is around 10 centimeters. Yes. So what is the thickness of one single paper? What is the thickness of this single paper? This is approximately, let us keep this approximation. It's a good approximation, 10 centimeters more or less. So what is the thickness of one paper? This number divided by 500. So the thickness of one paper is 10 centimeters divided by 500. And if you simplify that, it is 1 over 50 centimeters. Yes? Now, you want to see how much would be the height of this tower if I have this many papers? What should I do? If I ask you, what is the height of 10,000 papers? How do you calculate? It's extremely simple. You take 10,000 and multiply it by this number, which is around how much? 200. So it becomes 200 centimeters or 2 meters. Yes? So if I put 10,000 of them on top, it would be around 200 centimeters or 2 meters high. A little bit above my head. Yes? Now I want to increase. If I put 100,000, it becomes 20 meters. Yes? Now the question is that at the end, if I put this many paper, how high will be this tower? How should I calculate? Just tell me. Don't calculate. Just tell me what to do. What should I do? I take this number, whatever it is, and multiply it by that number. Multiply it by 1 over 50. But the answer will be 2 to the power of 64 divided by 50. What is the unit? No, not number. This is the height. Centimeters. Yes? So this is the number that I get. And then we have to calculate this number using GeoGebra to see if it works. And of course, I think I will use, I don't know if GeoGebra is capable of giving you that, but let me just go to Wolfram Alpha. That's also good to know about it. That's a free website, at least partially. Okay, so for example, the website that is also good to know about, that's a very famous one, Wolfram Alpha. So if I just type Wolfram Alpha, so and then I just go here. Okay, now what we want to do, we want to calculate 2 to the power of 64. Let me put a pair of brackets around that. So this is this number, and then I want to divide it by 50. Okay, and then I get a number here. Yes? And let us see if I can get something. It gives you a lot of different numbers, which is a little bit strange. So this gives you this number in scientific notation. So yeah, this is your number at the end. This is the exact result. Okay? So it doesn't seem a very big number. Yes? That is the number after you calculate. But let us really understand how big this number is. So if I divide by 50, let me ask you a question. This will give me the height of the tower in centimeters. How many meters? If I want to have it in meters, I should divide by what number? Can you tell me?
100.
So I have to divide by 5,000, yes? Yes, instead of 550, I have to divide by 5,000. This gives me in meters. Yes? Now assume that I want to have in kilometers. Might be it is a little bit strange for you that I am just changing to kilometers, the height to be kilometers. Let us try to do that. If I want to express it in kilometers, I have to divide by an extra factor of 1,000. So it means that I have to add even 3 more zeros in the denominator. And then let us calculate this again. Okay? And this number is this number. That's a mixed fraction. This number kilometers, forget about the rest. Yes? This is the number that you get. So this is the axis. 3.5 trillions. And that is still bigger. Yes? Is that clear? So that's extremely big. Let us compare it with another thing. I want to see, let us have a nice feeling, a little bit sci-fi thing, yes? But we divide it by 150 million. Where did I bring this number? Do you have any clue? 150 million? So I divide the whole number again by 150 with 6 more zeros. 2, 3, 1, 2, 3. 150 million. Still, do you think it's big or small? It's still big because that number was 3.5 trillion. What is trillion? 1,000 billion. What is billion? 1,000 million. Yes? So then I divide this one. Let us see how it goes. Still, it is quite big. But that is reasonably good. 24,000, a little bit above 24,000. This 150 million kilometers is the distance from Earth to the Sun. Yes? From Earth to the Sun is approximately 150 million kilometers. So it means that this is approximately 24,000 times the distance between the Earth and the Sun. So if I have that many papers available, that's a quite big resource of papers. Probably don't even have that much resource in paper. So if I take that many papers and put them on top of each other, when I reach to, I don't know, 100,000 of them, the distance would be, the height will be 20 meters. But if I still continue and do it for that one, then the height will be 24 times larger than the distance from Earth to the Sun. Yes? So extremely big. So you should have a respect for these kinds of powers. So sometimes you see that in the market, you say that the prices are going exponentially high. So 2 to the power 10 was reasonably very small. It was just 1,000, around 1,000. So if you multiply 10 to 2 to the power of 20, it would be roughly around 1 million or something. But suddenly it starts increasing, so that when you reach the 2 to the power 64, what happens? It becomes that big. So have respect for 2 to the power 64. So in mathematics we can make it bigger and bigger, but in reality and physics probably we will never encounter those kinds of numbers unless in astronomical units. Yeah, these numbers can appear there. Yes, but even I don't know. Let me just guess. If I ask you the total mass in the universe, the mass of the Earth, the Sun, galaxies, and everything, if you add them up, and I ask you to write 10 to some power for the mass of the whole observable universe. Yes? No, it's not infinite. By the way, I want you to understand, infinite is just in your head and in mathematics. It's even extremely bigger than this number. This number is even not close to infinity. Yes? Yes? So what I'm saying is that assume that I put all these masses in the universe, the whole planet Earth, Moon, Jupiter, Sun, galaxies, everything, put them in the scale, and then I ask you, what is the weight or the mass of this? It is 10 to some power. I want you to guess the power, the exponent. What is that? No, I just want you to understand how big the powers are. It is just 53. Yes, this power is just 53.
For what?
I just told you. The whole mass of the whole universe, including galaxies, stars, and everything. By the way, you can view the Earth. You can take 1 million of these Earths and put them in our Sun. So the Sun is 1 million times larger than our Earth. Now assume that I have this mass. You can feel how big the Earth is. And then the Sun is one, and then the Sun is the smallest, one of the very small stars in our universe. Okay, so if you put all those masses together, I was thinking that you might think that the exponent should be extremely high. But no, the exponent is just 53. But it doesn't mean 10 to the power 53 is not that big. It's extremely big. Because 10 to the power of 64, 10 to the power of 64 was a very extremely big number, let alone that you have the base to be 10. So the exponential growth and then something being exponentially big, I want you to feel that it is really big. Yes? Okay, that's good to understand that. Unfortunately, I forgot to switch to the camera mode, but I recorded my voice. Anyway, so that is also good to know about this wolframalpha.com. It will give you a lot of answers. So you see that when I asked question from Wolfram, it didn't just provided my answer. This is a little bit AI. So it was trying to guess, if you are asking this question, what might you need? So it is presenting, for example, the exact form, decimal form, exponential form, whatever it can provide you around this number, around this question. Okay, So let me just stop this here. Let me see what else I can do here. Now let me just clean that one and then I can close this. Another time.
That's crazy. How does he do these quickly? Yeah, because they release the show. Looks so good. Yeah, so they can turn really fast. Amazing.
Okay, so now let us go and try to see how mathematicians have defined if I go to negative but still integer powers, integer exponents. For example, I want to see what is the meaning of 2 to the power of 3, minus 3. It is very, I hope that this is clear for you. You cannot do this in the same way that I started the lesson today. You cannot say that I multiply 2 by itself negative 3 times. It is nonsense, yes. So, but if you take this in your calculator, you will get an answer. We want to see how the calculator is calculating that number. There is a definition behind that. And I want you to memorize that after. So because that is just a definition of this, so you have to start remembering. So, what happens if I have negative exponents, but still integer? So, this is the way that we define it. If I have a to power minus n, this is semicolon equal to, it means it is defined to be 1 over a to the positive n. Yes? So remember, this is something very important to have in mind. Of course, in this case, it is important that you know a isn't 0. Needless to say, because if a is 0, the denominator becomes 0 and I am in trouble. Yes? So for example, if I ask you what is 2 to the minus 3, you can use GeoGebra or calculator to see this. But how they calculate it is like this. They will write, they see 2 to the negative exponent. We cannot say 2 multiplied by itself minus 3 times. It doesn't make sense. What makes sense is to use this definition. So you write 1 on top over, instead of 2 to the power of negative 3, you write 2 to the power of positive 3. And then you already know what is the meaning of 2 to the power of 3. What you need to do, you need to copy and paste 1. Instead of 2 to the 3, it makes sense now. 2 times 2 times 2. Yes? And the answer becomes 1 over 8. If you want, I don't know, some softwares are capable of giving you fractions, you might see this number on the display, which is also the same thing, 0.125. But anyway, how they calculate it, they are following this rule. So if you have 2 to a negative power, if you have a number to a negative power, follow this rule. Yes? Okay, now I want you to calculate some things for me, okay, here. For example, what do you think about this one? I have minus 2, but the pair of brackets around it to the power of negative 3. So don't get confused. Might be you have a lot of negative signs going on. You need to understand what to do. Let me ask you again. What is this in mathematics? This is called the power. Let me again be patient. What is the base? Name it. Minus 2 is the base. What is the exponent? Negative 3. As soon as you say it is negative 3, it is not the simplest version. It is this version, that you have a negative one. So you need to remind yourself about this definition. So what you do, you put 1, you put a fraction line, and then you take it down. How? Which one I am supposed to change? You see, this A is going directly and exactly here, no changes. The change is happening here and here. I have to take the minus sign away. So it means that I put the minus 2 here as before, because I am supposed to put it here exactly. And then instead of minus 3, I put 3. Yes? And then I calculate as before. I would say that I copy and paste this one part. And then I ask myself, can I calculate this? Yes, because now it is positive. I say minus 2 times minus 2 times minus 2. And the answer becomes how much? 1 over minus 2 times minus 2 times minus 2 is minus 8. You can keep it in that way, but I myself prefer to put the minus sign in front. It doesn't matter that much. So if someone asks you what is minus 2 as a whole to power minus 3, the answer is negative 1 over 8. But that is the source of how you have to calculate. Okay, let me ask you this question. What is minus 2 to the power of minus 4, but in this way of writing? So this is not something that in the exam you ask me, is there any parentheses or not? You need to understand it yourself. I give you this combination, and I ask you to do that. So how I'm supposed to do it? Yes?
Since it's not in parentheses, the base is 2.
Yes?
The base is not negative.
So what should I do with the negative sign then?
We multiply it later.
Okay, later means keep it for the time being here.
Yes.
And then forget about this. Yeah, and do this part. So it becomes 1 over 2 to the 4. And then I start copy and pasting this part that I am not going to change. But this one is 2 times 2 times 2 times 2. And then it becomes copy and paste, it's 16. The answer is minus 1 over 16.
So, and what's the number minus 2?
Yeah, bro. No.
Yes? So today I want to stop here. I don't want to continue more. But what we learned is about the exponents and powers. But we still, let me ask you some questions to understand, to see understanding is correct. So we started with these numbers for exponents first. Yes? This was the allowed possible values for the number on top, the exponent. Then I add one single number to this list, which was 0. And I told, for example, 2 to the 0 by definition is how much? 1. And I try to motivate you why it's a good convention. And then, if you are a mathematician, by the way, this is the way mathematicians work. If they know something for some particular values, they are always thinking what happens if this is not the case. Let us explore that. Of course, you know that there are many numbers that we haven't addressed yet. The most natural one coming later is the negative integers. So now, if I ask you, do you know what happens for these powers? You would say yes. So I expanded my list. I started from these positive natural numbers, and I add 0 to my list, and then I added negative numbers to my list. So in the future, there are other type of numbers. So for example, if I ask you calculate this one, if you put this in GeoGebra or calculator, you get a number, but that number is not using this rule nor the initial rule, because 2 to the power of 1/3 doesn't mean multiply 2 by itself a third number of times, which is nonsense, and it also is not negative that I can use this one. So it means that I need to a new definition that covers the fraction numbers. After that, even if I understand what happens for fraction numbers, then still I don't know what happens for this number, 2 to the power of a square root of 2. Or if I ask you what is 2 to the power of pi, because these numbers cannot be written as fractions. They are irrational numbers. But even if this is the final point, which is above the high school, okay? So what happens if I have 2 to power an irrational number? So I will talk a little bit about these powers as well, but the main part is to add fractions here. After that, the lesson of exponents are finished, then we have to practice a lot to be very quick and fast in harder problems. Because after you understood what's going on, at the end of the day, you have to be fast in your calculations, have a good understanding of what is going to happen. Okay, so that is what we are supposed to do next time. I want to start giving you some rules for just these exponents, and after that I will tell you what to do with fraction powers. Okay? Any questions? Okay, so yeah, I stop here, and then I will give you time to practice a little bit on if there is something left. I saw there are some good questions in the book, by the way. And those are the questions that you have to pay attention for the exam. Any questions so far? Yes, please.
Which page can we practice this?
I will write it down now. Yes, but I think there are many exercises. I don't know. Have you finished everything so far? If you haven't done that, don't waste your time. Just have a break for 5 minutes and then start. Still, there are 30 minutes left.